Hey guys, so welcome back. In this video, we're going to be talking about how to solve equations using 3 different methods. I think there's more, but we're talking about 3. Factoring, graphing, and square root. So one main note that we're going to want to take is solving equation means when it's like touching the x, like the x-intercepts. That is the solve form. And there are only 3 possibilities for this, okay? So I'm gonna make a mini little layup. So the first possibility is that your graph is like this. The vertex is on the x-axis, meaning there's only one solution because it's one x-intercept. Another thing that could happen is yours is like up here. That means there's 0 solutions because not touching the x-intercept at all. And the last possibility is like this. Oh my god, that's such a weird parabola. But if they're touching it 2 times, there's 2 solutions. There is no other type this could be. So yeah, there's always going to be either 1, 0, or 2. Should have said that in order. Solves x-intercepts. And a lot of people call these zeros too, and that's what we'll be calling them throughout this video. So first, I'm going to show factoring. Alright, so factoring method is really going to factor it and, wait, that's kind of slow. But let's just do this one to start us off. So I had this equation. Alright, and I wanted to solve for the x-intercepts. So I could graph it, I could square root it, but I'm showing factoring. So first, I did this in a previous video. I'm just gonna factor it, okay? I'll just use the AC method, right? And do it all. And the factored form is x minus 3. Go watch my other video if you did not understand how I did that. So that's our factored form, right? And just be sure it's equals 0. It's all gonna be like that, but I'm sure I never doubt that. And now we gotta see. So here's a rule that you're gonna wanna remember. If A times B equals 0, right? Either A or B, it has to be 0, okay? So say we're labeling this A and B, okay? So either this is 0 or this is 0. So let's solve this. How can we make this 0? What minus 3 equals 0? Well, that's like 3 minus 3, right? So if we substituted that for a 3, you'd get a 0, and 0 times this would equal 0. And for the other one, it's the exact same thing, 3. So there's only one solution, which is 3. Okay, so another one that we can do is x squared minus 6x, how about that? So this isn't the exact same thing. It's not a trinomial, but it's a binomial. But we can still factor this, right? What is something that we can take out of these two? We can take out the x. So if we divide both of these by x, we will get, right? So now let's label this A and B. So one of these has to equal 0. So for this first one, obviously x has to be 0, right? Just one solution. And for this one, 1 minus 6 equals 0. 6, right? And that's like all the possible solutions to make this 0. And you can even plug this in, like 6 minus 6 equals 0, times x equals 0, or the other way around. Alright, so enough about factoring. How about square root? So that's another really, that's another really efficient method for some cases. Like you're always going to look at your equation and be like, which way would be the best for this? So square root. Say I had, it's like solving it. So say I had x squared minus 36 equals 0, right? So to square root this, I'm just gonna solve it like a normal equation. Solve for x, okay? So plus add 36 to both sides. So we're gonna have x squared equals 36. And I'll solve for x, we're gonna have to find the square root of each of these, right? So that's square root x to get rid of that. And that'd be x equals, what's the square root of 36? the square root of 36 would be 6. So that's 1 square root. Of course, not all of them are this easy. Okay, so another one would be, okay, let's do this one. 4x squared minus 16. Alright, so say we had that equation equals 0. Oh, I forgot that. So what's the first step in this? Well, the easiest first step would be to add 16 to both sides. Right? Just cancel these out. And I'm just doing it step by step in case you didn't get what I did. 4x squared. And before we even square root this, the best thing to do is divide it by 4, right? So we have x isolated. Okay, and that, so that cancels out. And so x squared equals 4. Don't mind this, I messed up. And now we can square root it since x is almost completely isolated, minus the exponent. And that equals x equals, come on guys, what's the square root of 4? 2. That's funky too, but you get it. So that's how square root is. If you have simple equations, like, you know, let me just do one more, right? If you have one like this, then negative x plus 9. Actually, this seems like a fun one. Let's do this. So first, we'd want to subtract 9. And we cannot square root x when it's negative because, as you all know, negative numbers cannot be square rooted. It's called a complex number, and that's complex stuff. So that's like divide. That's like an invisible -1 there. Just divide this by -1, -1, and then we have x squared equals 9. Square root them both. X equals 3. So any small equation, something that you can square root it by, unlike this, would work pretty well. And for these types of equations, right, where you can't square root it as easily because there's multiple occurrences of x or something with different exponents, use factoring. And for our very last method, we're going to do graphing. Let me just grab a new paper. Okay, new paper. Pretend the title is still there. I might put that as text or something. Ooh. Anyways, graphing. Let's add some charts over here. Okay, so now these are my graphs. They look like spiky little thorn thing. But anyway, I'm just gonna put an equation on top of each one that I'll dedicate to it. This one could be x squared minus 5. It's a pretty simple one. And this one could be a little complicated one. Half times x minus 4 squared, x squared minus 2. Okay, so let's start off with this one. I talked about transforming in my past math video, right? This is the parent function. I'm just going to label that PF. And this is the anything else in the transformation. So remember when it was not in parentheses, it was like this? That's an up and down. So this is -5. It's like the same thing as saying down 5. Okay, so listen, move our whole entire vertex down by 5. 1, 2, 3, 4, 5. So there is our vertex, making it nice and big so you can see it over all the lines. And now, because this is like, you know, regular parent function, I can just use the 1, 3, 5 method to graph it. So meaning like you go up 1, right 1. And then from here you go up 2, right 1. And that's a good 5 points to put my line. I'm just gonna make a nice, appropriate, approximate for the rest of this, yeah. And arrows because they go on forever. Okay, so that is our first graph. So now the point of this was to solve, right? To solve for the x-intercepts. So let's just solve this, okay? I know my lines are a bit messy, so it's kind of hard to tell. Like, that's like, there you go. 1, 2, 3, 4, 5. So like right there, that's our next point, as you can see, right? With those lines. I don't know why I did that. I just did that to like show. But for the x-intercepts of each of these, I'm just gonna make an approximate. So 1, 2. That looks like 2.5. 2.5. And our other one is -2.5. that's a true solution one right there. Okay, so that's that one. And I'm sure if you did the square root too, it's not as easy because 5 is not square rootable. But, you know, you'll kind of get something around this. Okay, next one. Okay, so for this one, I'm going to graph this just like we did the last one. So remember, if it's inside a parenthesis, it's left to right translation. That is to the right by 4. And this is down 2. And this is just like, you know, changing thickness or thinness. So let's graph the vertex first. So 1, 2, 3, 4. 1, 2. And closer to 0, the wider it gets. So there's like a little bit of a different method to graph this one. Right, so instead of going up 1, left 1, it's up 1, left 2. My gosh, they won't be great. And from there, I'll just like graph it. Actually, we'll need 5 points because this could be like this too. And for the next point, maybe like right there and right there. Now I can graph this. Arrow, arrow. And that's how you solve with graphic. Oh wait, I didn't even tell you what the answers are. So let's see where this one is. It's pretty close to 1. And this just has lots of approximations. So it's about 1 and 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And like 7.5-ish. So those are the answers for this one. So I hope you guys enjoyed this solving video. I have a few more videos coming soon. Don't worry. And yeah.